Aufbau order. Ever since the work of Niels Bohr, who determined that electrons reside in shells, where we have the nucleus and then the electrons residing in the first shell, the second shell, the third shell, a very simple model, we've now come to understand that there's details within that. For example, now we know that sure you have the first shell, but you also have a second shell which has details within it. We call that a p orbital. Specifically, we'd call that a p sub x orbital. There's a p sub y and a p sub z. So the 8 electrons in the second shell occupy 4 different regions. Going to the third shell, there's a spherical region, but there's also more p-shaped regions, just like we saw before. And that would be 18 electrons into the atom. And let's go ahead and look at that in detail, the Aufbau order up to argon. These are called atomic orbitals, which are pairs of electrons. We'll create a little table here where we'll show you the principal shell number, the electrons that go in it, the atomic orbitals within that shell, and put it all together to what's called electron configuration, a method of bookkeeping to keep track of where the electrons are in atoms. We have the level, the orbital, and the number of electrons in it. Once you get used to this, it gets very repetitive. After all, Aufbau is German for build up, and we always build up in the same order. In the first shell, we have 2 electrons. That brings us up to helium, which is a noble gas, a full outer shell for the first shell. It is a spherical orbital. We'll call that S, and the order we're going to follow is S, P, D, F, then alphabetical, G, H, I, etc. There it is, the 1s orbital. There's the nucleus in the center. This is given the designation 1 for the first shell, S for spherical orbital, 2 for 2 electrons. The electron configuration of helium is 1s2. Moving on to the second shell, it can hold a total of 8 electrons, consisting of 1 s orbital, that means 2 electrons in the second shell, spherically shaped, so we're going to designate that as 2s2, and there it is shown there. But we also have 3 sets of p orbitals. That would bring us to a total of 10 electrons, right? 2, 4, here's the p sub x, here's the 2p sub y, and there's the 2p sub z. You can see the nucleus in the center. And overall, that is 2p6 for those 3 atomic orbitals. We're now 2, 4, 10 electrons in. The electron configuration of neon is 1s2, 2s2, 2p6. See how we're providing details more than just the principal shells? For the third shell, there's once again a spherical orbital. So now we're at 3s2. That's calcium, I believe. And we have our 3 orthogonal, that means perpendicular, in 3 dimensions, orbitals in the third shell. 3p sub x, 3p sub y, 3p sub z. The electron configuration of argon is 1s2, 2s2, 2p6, 3s2, 3p6.